just give me a thumbs up, and I'm going to rock and roll from there. Huh? What's it?
Can we get the slides in case this thing doesn't work?
All right. Sorry, man. Here we go. We got it going.
It'll be good. All right. Okay, let's go ahead and get started. The word of the day, this is a new phrase to me. The word of the day is credential material, okay? Kind of like genetic material, but with credentials. So let's jump into browser pivoting, a project I call Fu2fa. In typical fashion, here's what we're going to talk about. I'm going to introduce browser pivoting as an idea. I'm going to talk about where it came from, why I bothered, and then I'm going to take you through this kind of like mental journey that I did not think would work. I really didn't. That's why I didn't do this thing for 6 months. I'm going to take you through this mental journey of something I didn't expect and show you how I arrived at kind of browser pivoting. I'll demonstrate it and then talk about a few limitations as well. Okay? That's good. So what is browser pivoting? Let's just get this out of the way right away. Browser pivoting, it's a post-exploitation capability. It's a way to inherit a user's access to websites by relaying requests through their browser, okay? I've always had a fantasy of having an invisible tab in someone's browser that allowed me to go to anything and do whatever they were doing while they were doing it. And that fantasy is now true. Just a little bit about me. My name's Raphael. I develop Armitage and Cobalt Strike. I run a company in Washington, D.C., Strategic Cyber. Cobalt, it's commercial. It allows me to eat, and I like eating, as you can kind of see. So yeah, that's a little bit about me. So let's talk about how this came about. So one thing you're going to notice as I go through browser pivoting, it gets around two-factor authentication, and that's cool. That's a side effect. It actually does more. It's very generic, but I started on this problem because of two-factor authentication. So in April, I was in Puerto Rico, and I'm sitting at this kind of swanky bar outside with my friend Chris. Chris is a really good red teamer dude, and he's in the front row. And some swingers came by and tried to pick us up. And I'm dead serious, that happened. What? Oh, well, you said I could talk about it? Oh, well, whatever. So anyway, some swingers came by and tried to pick us up. And they were interrupting this beautiful conversation we were having about a problem I should work on. Chris is like, hey, Raph, you know, particularly in like some high security environments, two-factor authentication is starting to become more and more commonplace. And you claim you're working on threat emulation. If you could give red teams and pen testers a way to kind of get around two-factor authentication the way, you know, some actors do, that would be really helpful. And I was like, oh, that's cool. Maybe I'll give it a whirl. I think I've got an idea. Probably won't work, but I'll try it. So that's kind of how I got started on this was, hey, this will help. Okay, I'll try it out. So how might a motivated attacker respond to two-factor authentication? Well, as I said before, I had an idea. When I have an idea and when I set out to solve a problem, I always scope it, okay? I never expect that I can solve a problem for all possible use cases. I mean, that's just a straight up reality. So to make this problem tractable, something I could feasibly accomplish, I chose to focus on Internet Explorer because that mapped to my idea, and I chose to focus on Internet Explorer because that's what's used in a lot of enterprises. Remember, I'm not interested in pen testing tools for paranoid home users. I'm interested in risk demonstration capabilities for enterprises. And Barry, you'll probably notice this is the ACE format, right? Problem statement, assumptions. A few people here know what I'm talking about. It's kind of cool. So anyways, target uses Internet Explorer. I also assume that I, the attacker, have control of the target system, okay? So somehow I've hooked their system. It could be maybe they clicked a Java applet. It could be something else. One way or another, I'm on a box. And last but not least, not always required, but just a safe assumption, we have to assume that if there's a target I want, a website that has data I want, that the target will interact with it, okay? And that's necessary for having something I can write on top of. So we good with those assumptions? Okay. I guarantee I'll get questions. What about Google Chrome? What about Firefox? What about the next browser that will be developed by Martians in the future? I don't know. These are my assumptions, so this is where I live. So let me take you on a technical journey then. Let's start with Internet Explorer. This is some background now. Internet Explorer is nothing more than a dumb graphical shell that builds on top of a bunch of libraries, okay? And what I'd like to call your attention to is at the bottom of this lovely hierarchy is a library called WinINet, okay? WinINet is the Windows Internet API. It's very popular with malware developers. It's popular because in a few lines of code, even in C, I can make a request to a URL and get data back. Very, very simple to work with. Very, very high level abstraction. And WinINet is the communication layer for Internet Explorer. Internet Explorer doesn't cheat on WinINet. It doesn't have another friend that it uses to communicate. It's only WinINet. So, what does WinINet do besides help malware? Well, I mentioned before it's an easy abstraction for HTTP, HTTPS. But WinINet also manages the browser cache, history, cookies. It handles authentication. So, your basic auth, NTLM, and Kerberos. It also handles managing state for secure and non-secure connections, and this is pretty important. So WinINet does a lot. So let me take you through a little bit of my experience with WinINet. This is kind of the inkling that led to a potential answer to Chris's question. This is some code to basically create a cookie header and send it with an HTTP request via WinINet, okay? So all I'm saying is, hey, open an HTTP request, a GET request for the URL/check-in, and I'm sending whatever headers I got, like whatever cookie I want. And this code is from when I was trying to make my malware beacon covertly send data as a cookie, okay? I quickly became frustrated though. How many of you have worked with WinINet? A few of you, okay. I became frustrated because I would put strings in there all day long, and I would look at my web server, I wasn't getting a cookie back. That made me really sad. I was like, what's wrong with me? Can't I write malware? So I didn't know where my cookie was, and I was really, really frustrated. So I went to MSDN, and I read, and I read, and I read. And I learned that there are flags I need to set. For example, if I set internet flag no cookies, okay, I have to set this with my request. If I set this with no cookies, then and only then will WinINet let my cookie through. If I don't set this flag, WinINet will say, hey, that's nice, you've got a cookie header you want to send, but I'm WinINet, I manage cookies. I'm going to put a cookie in your request. I'm going to go into the credential store, I will get the cookie I want, and it's going to go there. So, another thing, this is straight from the documentation on MSDN. Another option is Internet Option Suppress Server Auth. What does that mean? Quote unquote, do not reuse credential material when you authenticate to a site. So if I make a request with WinINet, and presumably, maybe a user has, that process is already connected to that website and authenticated, there's now credential material associated with that particular request, and WinINet will automatically re-authenticate over and over again. And this makes sense, because if I connect to a website, and I'm prompted to log in, I'm going to put in my username and password, right? Like I'm getting like the little, hey, I get the little, hey, login box. I put in my username and password, and I don't get a new login dialog for each image I download. I don't get a new login dialog for each JavaScript snippet I get, right? Yeah, I don't get that. So because WinINet actually manages that re-authentication for me, okay? Now, as I keep building up, are you kind of seeing an idea of something magical that could happen? I see nods of yes, yes. So, here's the theory behind browser pivoting. What if, fantasy hat, what if I wrote a proxy server? Just a plain Jane HTTP proxy server. And what if I made this proxy server receive a request and translate this request into WinINet calls, okay? So I get a request from a client, a browser, and I decide to fulfill that request with WinINet. I get back the result, and I return that in a form that the browser expects. That's cool. So I got a proxy server, fulfill stuff with WinINet. Now, what if I inject this proxy server into the user's Internet Explorer as they're using it, because I'm on the box? There's session state associated with WinINet, right? There's those cookies that get put in whether I like it or not. There's credential material that gets reused whether I like it or not. There has to be a boundary for that state where WinINet assumes that this is the same consumer, I'm going to reuse what's already been done, right? So the idea here was maybe that's the process. So we got a proxy server injected into IE. And I'll do a demo later, but the idea is if I make my request with my browser, it goes to this proxy server, my unauthenticated request should, in theory, come out authenticated as that user. Their cookies, their credential material, which by the way is not just usernames and passwords, but client SSL certs too. That has big implications. So this is the theory. Does it work? So spoil the surprise and say, yes, it does. I knew from the documentation I would get cookies. I didn't expect that any kind of like basic NTLM Kerberos auth I'd get that. And I certainly didn't expect that I would also get sessions, SSL sessions that were secured with a client SSL cert that the user had to present with a hard or soft cert. It works. So now that you know the theory, now that I've kind of given away the big surprise, before I jump into a demonstration, I want to take you through a few details because there are details. There's always details. Hacking is about details. And I just want to talk about some of the design decisions I had to make and why I made them to kind of just give you an idea if you choose to build your own. So these are like my lessons learned. And some of my decisions were probably wrong. Don't hate me. I'm just doing the best I can. So first off, let's talk about SSL. But before I can talk about SSL, I need to talk about how an HTTP proxy works. An HTTP proxy request looks just like a normal web request, except instead of verb, URL, whatever, verb URI, like whatever resource I'm requesting, it's verb, the whole URL, and all the headers and post data and everything else. Okay, that's what an HTTP proxy looks good like. This is good because as the developer of the proxy server, I can parse out that URL, parse out those headers, turn them into a WinINet request, and fulfill it, right? Good? We run into a problem though. SSL looks like this. If I do connect, whatever, 443, it is expected, if I, the browser, do that, it is expected that the proxy server will upgrade the connection to SSL, and the browser will be free to basically speak over this tunnel, okay? And this is bad, because I don't know what's being transmitted. And I see like a sad face from somebody. He's like, are you telling me there's no SSL? Are you kidding me? And actually, no, I'm not, because I got around it. Got to allay the fears. So right now, this is bad for me, because I cannot translate what I can't see into a WinINet call, okay? So what did I do? Right, wrong, or indifferent, this is the way I went about it. I decided to break, this is for the attacker only, not for the user. On my system, I have a proxy server running, okay? And what this proxy server does is intercepts any SSL request and presents its own certificate. So it says, hey, here's my cert. And if the browser accepts that certificate, it's then able to my local proxy server is able to get back the whole request and translate that to something simpler for my DLL that's living in the target in their browser to process. So I just change it to, I get the whole request, I do get HTTPS, whatever, so I can translate that into a WinINet call, and I send that to the browser proxy server, okay? So there's two proxies involved here. And the basic idea is, because my browser has an SSL session with my local proxy server, and if it's good communicating that way, so long as it gets the data back that it expects, everything works, okay? So that's how I dealt with SSL. One of the challenges to this, though, is your browser might complain and say, hey, I don't trust this certificate. And I didn't create a master certificate with some wildcard for every site. I probably should have. But in any case, my proxy server will present the certificate, and my proxy server is smart enough to tell if your browser broke the session because it didn't trust the certificate, okay? And if it does, it reports to you and says, hey, you need to add this URL to your trusted host. But once you do that, and for each website you might have a couple items, but once you do that, you're good to go. So this is kind of like a usability thing you should be aware of. Next, user agent string. WinINet does not replace the user agent string I send with the user's user agent string. It passes whatever I send through. And a hard lesson I learned is that some sites, they do serve content based on the user agent string. Like they may say, hey, you're an IE client, I'm going to send JavaScript optimized for IE, right? But if I'm browsing with Firefox, which is where I did all my testing, that's not going to work, and I'm not going to be able to interact with the website. So at the end of the day, I opted to pass the attacker's user agent string. But that's something that's in your control. Like you can use a browser add-on to change the user agent string if you want to. So you could use a browser that matches your target's IE as closely as possible and have an add-on that changes that user agent string. Whatever you need to do, one way or another, I punted on this problem and made it your problem. So, but be aware of that. I mean, this is kind of like the safety and handling of this capability. Next, browser cache. Something else I've learned with WinINet. WinINet will read from the browser cache. That can be bad, because if I request JavaScript and it's cached, but it's cached the Internet Explorer version, that might not be what I want. So I found it was really healthy to do internet flag reload to force WinINet to give me the actual site. Also, because I don't want to screw up the user's experience and have the browser cache my JavaScript that I request for Firefox, I use internet flag no cache write to avoid polluting their cache, okay? This is a design decision I made. Now, I'm not a forensics person, but let's say I'm a bad person and I want to frame somebody. I have a theory. If I didn't take this route and I decided to proxy a browser close to the user's browser through their browser, and I did all kinds of bad stuff, because WinINet manages those cookies and it manages the cache, I wonder what it would look like to a forensic expert, how close it would look like the user did it versus an external attacker, because the evidence is in their browser. That's scary. I don't know the answer to it. It's an open question. But for now, I skip the cache just for stealth reasons and making things work for me. Now, let's talk about process and state. I mentioned before, somehow that state's got to be recycled, right? If I connect to a website once and I authenticate, and the browser's going to re-authenticate for me, what's the boundary of that? And I explored this question. So here's the basic answer. If I have an old version of IE that's not tabbed, it's going to be a single process. Inject into that, and you're good. If I have a new Internet Explorer, basically what you end up with is a parent process and one process per tab. The parent process for IE, and it's called iExplorer.exe, which is confusing, it does not have the state. But the children, the tabs, any of the child tabs of iExplorer.exe, They have the state and they share it. So it doesn't matter which child process you inject into, they all share that state. How? I don't know. Why? I don't know. But they do. So, long story short, inject into a child tab process. If you're not getting a user's information or session, you are in the wrong process. And in the dialog I created, this is what it looks like. And just to show you how to identify it, PPID is the parent process ID. So you can see explorer.exe, its process ID 3348. You see iexplorer.exe, 3348 is the parent, that's the parent IE. Process 2100, 3992, its parent's iexplorer.exe, so 2100 is a tab. Okay? Make sense? Okay. It's just, again, situational awareness kind of thing. So, with all that, let's do a demonstration. So I've given you kind of like everything about it now. Okay, this is my first time ever trusting the internet at a conference. So, which one of these do I want to use? Okay, so what I'm going to do is I got to give myself an interpreter session, so I'm going to just task my beacon real quick. Run Meterp, defining a listener, 9988, set. Choose. Okay. When this box comes back here in about a second, hopefully I'll end up with an interpreter session. Assuming I don't type like super fast. Let's see here. Okay, cool. So we got an interpreter session. Cool. Now, let's take a look at what the user's up to. Let's go ahead and open up their desktop and watch it via VNC. Come up, desktop. It does take a moment. There we go. So here's the user's desktop. And easier to see because I'm just going to go directly to it. And I'm going to load up IE. And I don't know, I'll go to like news.yahoo.com. Okay, good. Make sure my internet works. Now, let's do this. Better make sure my phone's not dead because of two-factor. Okay, good. So, what we're going to do, I'm going to set up browser pivoting right now. Right-click, Interpreter, Explore, Browser Pivot. And I'm going to go into the child process, so 2852, 3800, so this is my child. And I'm going to set up the proxy server 17787, hit launch. And I now have a browser pivot server set up. Cool. Let me point my browser to it. So let's go to here, let's go to Iceweasel, edit, preferences, settings. And that was an EC2 node because I like to test everything as much as possible in a real-world setting. So 127.0.0.1, 1787. Okay, feel good about that. And let's make sure I can go to a website. We'll go to DerbyCon, I guess. By the way, right now, this is going through the browser pivot. Okay? Tunneled through Meterpreter, no less. Now, let's go to mail.yahoo.com. And if you see in my browser history a domain, losenolove.com, I'm not a creep, it's a test domain I own. But I had a really creepy purpose for it initially, so maybe I am a creep. So, it was actually a money-making scheme. Buy me a beer sometime, I'll tell you about it. It was pretty bad. Okay, so let's see here. What I'm doing, by the way, I'm so used to doing this for my testing, I should really talk through it. I see it's telling me, hey, add these things to your trusted hosts, right? So I'm just going to add a couple sites. It doesn't really matter for my purposes, but just show you what that looks like. I'm going to go to encryption here, view certificates, import, or not import, excuse me, cancel, add exception, paste that in, confirm security exception, good. And doesn't matter. I just want to prove to you, like I got a Yahoo login screen. I'm not faking anything here. Now let's go back to the victim. Keep in mind the attacker can see everything the victim's doing if you're watching the desktop. So we're going to go to the victim. And let's go to Yahoo Mail. And I'm being asked to sign in. So I'm going to log in. And the great thing is, all these great websites have, like, option for two-factor authentication, right? I saw a big executive at one of these companies bragging in an article about how attackers are coming up with creative ways to attack people without two-factor auth but they haven't seen anything for two-factor auth. I hope they're not watching this talk. So anyways, I'm asking for a verification code in a moment. Hopefully I'll get one. Now is a good time to get to know your children better. Oh no, here it came. Okay, good. So I'm going to put in my code. And I'm in my email, right? It's cool. It's email. I like email. I got an ad. Ads are cool. So let's go to Cali. Let's go to my browser. Let's go to mail.yahoo.com. Oh look, I'm in their email. Oh, we're not done. I call these the crowd pleaser demos, but we're going to do the scary demos in a moment because I set up a test environment for them. So, but real quick, what I want you to see, I'm able to open stuff up. The user doesn't see it. I'm able to this is a very Ajax-y web application, okay? And if I want to, I can send phishing emails from their email. That's pretty effective, I think. Especially for relying on two-factor auth as itself a non-repudiation measure. Okay, that's awesome. Maybe I want them to do something. Maybe I can update their calendar for them. It doesn't really matter. I'm not there. Yeah, so get owned. This is the point. This is robust. It works. It's just magic. It's not a hack. It's a software engineering exercise. This is the way it works. So, okay, cool. So that's Yahoo Mail. We'll do another one, another crowd pleaser. So just promise me, if somebody's doing weird network layer 2 stuff, just don't take over my Facebook. I trust you. So, actually, hold on. Maybe I don't have to trust you. So let me turn on my proxy. I haven't tested it this way. I suspect it's going to work, so I don't really care. I've got an SSH proxy set up that's the port. Did I lose it? That's the question. No. Oh, I did. That's no fun. Ignore that. I can't even type. All right, cool. So let's do this. Let's hit OK. And now I've got my little SSH proxy set up. Let's go to Facebook. Looking good. Gonna log in. Facebook's another crowd pleaser. And that's important because Yahoo doesn't secure their stuff with SSL sessions yet. But Facebook does. So that makes a good demo. So, it's okay. I want you to see me here. So 3. Oh, is it? Oh, thanks. I'm going to unplug for 1 second. See, I don't even know what my Facebook friends look like, so I'm not going to bother. What's my first stuffed? Yeah, this is one I don't want you knowing. My first stuffed animal. That's a funny one. Whatever. So my grandma made me the stuffed animal. It's pretty cool as a bear. So either way, you know what's kind of cool about that? It makes the demo better. Why? Because I had to jump through a lot of hoops to get in this count, right? Naturally. I mean, who's going to hack that? Who knows my stuffed animal? You don't. Chris might, but that's because we were in Puerto Rico fighting off swingers, and we shared a lot with each other that night. Not literally. All right, so just give me 1 second here. I just got to sync my monitor. It used to be, okay, good. But you can see here I'm in Facebook now, right? So, we got a hitchhiker, right? Attacker's riding along. Let's open up my tab. By the way, keep in mind, Facebook, I opened it in another tab. It's not in the first tab, okay? That's really important because that child state sharing thing. So let me go to facebook.com. Yeah, I know, you don't trust anything, whatever. Add exception. So, I don't think I cleared everything, so I might have to add a few hosts for it to look right. Oh, yeah, I do. That's fine. No, that's actually good. It's good for you to see this because now you can know how it works. Where's my browser thing? Okay, so I got to add like fbstatic.akamai.net. That's fine. So let's do this. Copy. Go back here. The good news is you do this once and you're good for like a year. So let's do this. View certificates, add exception. And somebody told me Midler has a much more elegant approach to the certificate stuff than what I'm doing, so I'm going to look at it. But the point is, I hit refresh, and look at that. I don't know the stuffed animal, but I am in Facebook. And if you want, I could bore you with photos of my friends. I just have to add like these static resources. Like you can see all the stuff it's trying to load. So I'm going to do that one just because I like you to see stuff. But the point is like, I'm in Facebook and I can do anything, Raphael can. Like I can interact with this web application. The whole thing is there for me to work with, okay? So that's important. So are we good with the cool social media demos? Now we can go scary? Okay, because these are cool. People understand Facebook. We relate to it. We've done email. Now, let's talk about NTLM. So those sessions were secured with cookies, right? I'm going to go to a wiki I set up on the internal network here. The internal network for my target, not me. And I think that's it. And let me just understand the risk, add exception, get certificate, confirm. And hope I didn't... Oops. What's that? Oh, yeah. Oh, that's why I screwed that up. Thank you. That's what I was troubleshooting before I got up on stage. But kind of cool, you know, whatever the user's proxy settings were, those are mine too. So let's go here, Internet Options. Let me turn that off. Thank you, by the way, for whoever suggested that. Because I would have probably been up here all day trying to figure that out and felt sad. So, all right. And I'm going to check one thing because my DHCP likes to, okay, that's good, that's what it needs to be. Now, let's do this without going through their proxy server like a dork. So, 172.168.131 was it? Yes. Do you see how I'm prompted like HTTP authentication? I don't know that username and password. These demos are very important because they show this is not just cookies, okay? I want you to really see that. So let's do this. Let's go back to the Windows box. We wait. The user goes maybe where we want. Another tab. 172.168.131. Yeah, and we don't trust any of my certs, whatever. They're going to log in. And here we are. We're in DocuWiki, right? Administrator. You can see that's my username. Let's go over here to Cali. Refresh. And I'm in DocuWiki. The point is, like, I can do stuff. Works. Now, scary demo. Scarier yet. Let's go to the IP address I don't remember. 137, I hope. It didn't change. No, good. Let's go there. Actually, I can't do it from this browser. There's a reason. I'm going to select a credential out of the certificate store, and it's going to be the first one by default if it's me, the attacker. So I need to show you this in another browser. So make sure I don't have any proxies set up because I have a lot of them lately. Let's do this. HTTPS 172.168.137. Oops, I actually do have that certificate on here, so that's not, that was my testing browser. So take me for my word on it. I'll show you the victim. That'll be better. So I'm being prompted to choose a client SSL cert. Okay, so I imported a few. So this is a soft cert, but the mechanism be the same if the cert was stored or presented some other way. But I mean, being asked to choose certificate. So you know I'm not making anything up. Which cert do you want? Because this will affect what it thinks I am. Do you want Mudge or administrator? Door number 1, door number 2? 2. Done. Administrator user. And because I got to re-add my trust star, but here you see I'm in this secure wiki administrator, right? Now, let's go to the attacker. And keep in mind, that's a SSL session secured with a client SSL set, right? So that's kind of nice. Let me go there as the attacker. Of course, I don't trust it. Get certificate, confirm. And look, I'm there as the attacker too, despite the fact that an SSL cert, a client SSL cert, was authenticating the user. I'm not going to sell my friends down the river. Let me just say this, and those who know will know what this means. This is a big deal. This is a very, very big deal. And if you're curious, there's another scenario you might be thinking of. It works there too. I verified it. I had a chance. Be scared. So, I've taken you through browser pivoting. I've taken you through a demonstration. Let's just wrap up with a few limitations. Will this work in other browsers? The answer is maybe. I don't know. I didn't work on other browsers. Firefox and Google Chrome use WinINet to get settings, but they don't use it to communicate. So the implementation I have as is will not work in those other browsers. What happens if the user closes the tab? Well, if it's the tab you're in, you lose the proxy. Just do the 2 clicks and go into another one. That's an assumption. The user's got to be browsing at the time. Are all sites full? Almost. I ran into something with Outlook.com. So I went to Outlook, and maybe it was my user agent being different, but Outlook email was basically the newest one that's cloud hosted by Microsoft. Basically says, hey, I think you're somebody else, sign in again. But what was really funny is I just clicked to like my settings page and went back to, or I changed like my browser pane preference, and then went back and it thought it was me and everything was cool and I could do whatever I wanted. So they're doing something, but it's not that hard to just get it to think it's you. I think it may be the user agent. I don't know. Other limitations. I had something I wanted to say to that. I just don't remember. But there's probably limitations. Oh yeah, now I know. This is a new technology. I've given you my experiments, my understanding. I don't know the full left and right bounds of it. Okay? I really don't. It was a software engineering exercise to see if it was possible. You can see it does a lot, so it's kind of cool. But with that, we've talked about browser pivoting, a technology to access a website as a user. I gave you some background. I gave you my lessons learned if you choose to build your own. I took you through a demo, and I took you through all my research, my understanding. The actual implementation I put into Cobalt Strike, so I've got a few DVDs left, or if you download the trial now, it's got it. And so with that, that's browser pivoting. I think we're out of time, right? This clock's off. Yep, it's 50 after? Cool. Guys, if you've got questions, come see me. I'll chat with you.